Hey, all, here I'm going to review how we use the normal model in order to find probabilities of certain measurements happening. So I'm going to do the first problem from our 7.3 lesson, if you have that still, or if you can go find that on Canvas, or you can just access it right here, where we talked about the liters of blood in an adult body. And so we should always document what it is we're given. So I am given an average of 5.2 liters. We're going to use the Greek letter mu to represent our average. We are told it's normally distributed. That tells us that we're allowed to use a normal model to find the percentage or probability that we're looking for. And then we have a standard deviation of 0.03. And so here we're talking about population. So population mean is that Greek letter mu. Standard deviation is that Greek letter sigma. It looks like the O with a hat on it. And we're trying to find the percentage of people who have less than, not a bad idea to, just write the less than symbol of 5.4 liters. So remember that we would always sketch a normal model. It doesn't have to look beautiful. Mine rarely do. Our mean goes in the middle. And then we could almost 100%, not all, 99.7% of all of the adults' blood volumes would fall within three standard deviations to the right or the left of this number. So we could go plus zero point 0.3, plus zero point 0.3, plus zero point 0.3, minus zero point 0.3, minus zero point 0.3, minus zero point 0.3. We don't need to do all that. That's a little bit extra for where we're at in the school year and what we're trying to, the purpose of this quick video. So I'm just going to put 5.4 wherever it would belong. So 5.4 would be to the right of 5.2 somewhere. It doesn't have to be exactly. And I wrote 5.2 instead of 5.4, which says something about where we are in the school year. And we're trying to find the percentage of people who have less than that. Percentage is probability, is area underneath this curve. Less than means go to the left. So we are trying to figure out what is this area of my curve. And that's where we would use Desmos to help us. I'm going to write it here first, then I will do it on Desmos. We would go in there and we type normal dist. In parentheses, we're first going to tell it our mean. So that goes in first, 5.2, comma, don't forget the comma, then goes in our standard deviation of 0.3. So the calculator now knows we have a distribution that is normally distributed. So it looks like this, where 5.2 is in the middle, and then we add 0.3 to the right a bunch of times, subtract 0.3 to the left. We need to tell it the minimum and maximum boundaries of our shaded area that we just did. Minimum is always what is the left side of your shaded area. Maximum is always what is the right side of your shaded area. So when I look at that green cross hatching, the right side is my 5.4. That's my max. The left side, well, you would think it's right here, but actually this goes on and on and on forever to infinity. So we'll leave that as negative infinity, which you probably know is the default if you don't type anything in there. So I'm going to go to Desmos and I'm going to type that in. I need to get rid of my pen tool. Just know I'm testing out a new program here. So if I make a couple mistakes, that's why. So my mean was 5.2, standard deviation of 0.3. Click that cumulative probability. We can click that little zoom fit so we can see and make sure that our picture looks close to what this picture was. Minimum was negative infinity. Maximum was 5.4. So it should look similar to what we've drawn. And this will give us the percent area or the probability that a person would have a volume of blood in that shaded region. So we'll say 0.7475. And we could just say equals 0.7475. If we want to make it a percentage, because that's what the question asked, but I'm not too picky, I would call it 74.75%. So about 75%, close to 75% of adults, based on what we know here, have less than 5.4 liters of blood in their body. There's some practice questions like this on the review. If you need any help with that, use this as a guide, use your notes from earlier in the year, and ask me.